Hey everyone. So my name is Erik Guzman, and I'll be talking to you about understanding GraphQL security, protecting your server from abuse. A mouthful. Just a brief introduction to myself. Yes, I am a full-stack software engineer at a software consultancy called Zeal. I am also a Microsoft MVP in developer tools. I do online content creation, and I also do some open source contribution work. And I've done loads of mentoring throughout the years, working with more experienced devs and junior devs. And one thing that's been kind of like a shared thing is that with GraphQL, they don't know too much about it. They're unfamiliar with the unique security implications of this. And if you're here for the last talk, you're going to see some similarities, but it's definitely going to be underscoring the importance of implementing certain basic security principles. And one last thing about myself is also I'm a Trekkie. So with that, we're going to do a themed story here, and we're going to be doing a story from Star Trek Lower Deck devs. So we're going to be talking about the perspectives of the devs have implemented a brand new Starfleet knowledge base interface, and it's powered by Subspace GraphQL, folks. It's awesome. So they've rolled it out everywhere. It's on all the starships, the shuttles, the runabouts, on the star bases, the star docks, the outposts. And it's even on all the terminals and pads. It's everywhere because GraphQL is so flexible. So let's just roll it out. And all the developers, they're used to REST. So they've moved over to GraphQL, and they've just applied the same overall principles that they learn from a RESTful API. They've added authorization, rate limiting, role-based access control, and they blocklisted stuff, all the standard stuff. And that means that our job is done, right? We've done all the basics of everything. We can call it good. Our API is secure. Not so much. I love to just highlight this quote I pulled from Black Hat GraphQL. And it says, a feature can turn into a weakness, a misconfiguration can turn into an information leak, and an implementation design flaw can lead to a denial of service attack. And with GraphQL, we got a load of new features in it that are completely different from our standard RESTful API. The basic thing is like with GraphQL and most of the time, and sometimes usually this comes by default, is we have graphical, studio, whatever you want to call it now. It's automatically disabled by default. Like in production, no one can use it. So we're secure, right? And also our API is not public because what's here in Starfleet, we don't allow access to the external API. It's just internal. Only on our star bases and on the starships can access it, right? No problem. I mean, security by obscurity, right? Not exactly. Well, Starfleet is pretty much kind of like a military organization, and we got moles. And Officer O is in Starfleet, and she is a Romulan mole. And she has been lying in wait for an opportunity to expose secrets, find out juicy bits from Starfleet personnel, and this new GraphQL stuff is perfect for that because it turns out that the devs, didn't implement it perfectly fine. And she is familiar with using the LCAR's element inspector, so she can immediately go onto the LCAR's terminal and easily see all the API endpoints, see all the requests coming through, so she can automatically already start inspecting everything and get going. So let's start covering the features of GraphQL. So the first one is introspection. And with introspection, O loves it. She brands it introspection. And this covers the same thing like in the last talk, where even though we've disabled something like graphical, that doesn't disable introspection. You can still do introspection by crafting a query and doing a request to GraphQL, and we can get some information back. So this allows O to do some basic reconnaissance on the GraphQL API. So she can learn about sensitive information, she can probe for new fields, and even though the devs have already pre-configured stuff and everything's secure, well, with misconfiguration, a developer can add in a new field, misconfigure it, and oops, Some information just got leaked for a brief second, but with the automated toolings, O was able to catch that information. So the solution for this is pretty basic. It's just disable introspection. Your mileage can vary based off the tooling that you use, depending on the different backend server implementation. Some will have it disabled by default. Some of them don't, and you have to actually add plugins in, or some of them don't even have plugins, and then you have to craft your own introspection disablement for that. Let's talk about some of the other basic things about GraphQL, so our fields. And just to go over some of the cool features with fields is field suggestions. So let's say we do a query and we misspelled homeworld. Well, it's really convenient for us developers because it's like, hey, did you mean homeworld? Awesome, great, super cool. O loves it also. So why does she love it? Well, we just disabled introspection, so we think we're safe from them being able to guess what's in our API. Well, she can just use an automated tool and start just randomly guessing names of fields using common, names. And eventually, she'll get a hit, and it'll say like, "Hey, did you actually mean crew medical records?" Well, all that hard work we just did to try to obfuscate our API, our schema, has just been exposed through the field suggestions. That's no good. So what we can do, so just to highlight it, is just like introspection workaround. So it just disables introspection. It gets around the disablement of introspection. It allows, again, for her to probe all those fields. And eventually, it can accidentally expose private information through misconfigurations and whatnot. Not good. So the theme is going to be disable. So in this case, disable our fields. All right, and once we do that, then ideally, if O tries to do anything clever, she'll just get an error saying, hey, just, doesn't work. All right, so another basic thing about GraphQL is the queries themselves, constructing queries, right? Nothing can go wrong with that. All right, so here's just to go over the basics, we're constructing a query. We're fetching for the federation. For federations, we're grabbing their starships. We're grabbing the captains for the starship. Cool. Well, O loves queries. She can take advantage of it. And she noticed that not only when you're doing a request for Federation starships and then the captains, but also the captains were probably serving on multiple ships, so she can request the ships. Well, then the ships have captains, so why not request the captains? And we can just keep on going and going and going and going and what we do is a cyclical request. This isn't good. It's like it keeps our data. It could keep the database busy. It can hog up memory, hog up CPU. It ends up locking up our servers. And the tricky thing is that it also bypasses our rate limits that initially us RESTful API developers, thought we were doing it because this is all happening in one single request. And unfortunately, we end up getting an information overload, and things get crashed, and O can easily crash our servers at the most opportune time. So how can we fix this problem? All right, well, if you look at the highlighted part, it's like there's an easy kind of waterfall approach where you see that we're kind of nesting things in and we keep on going inwards and inwards. And this is a depth. So the policy is to apply a depth limit to all our queries. So there's no need to go past a certain amount. So, you'd only need to go past 5, 10. It depends on your server, on your use cases. But if you apply a depth limit to all your queries, then you can prevent this sort of attack from occurring. And if O were to try to get cheeky again, she would get an error and preventing that sort of attack from happening. But O's not done with fields yet. She really loves fields. And O has a mantra: more fields, O problems. Why is that? Well, there's a thing called field stuffing. So let's say she's going to craft a request, and she's purposely going to craft this request so it doesn't exceed the depth limit. So instead of going deep, she's just going to go wide and try to just cover a bunch of different fields. So she's intentionally targeting fields that are large lists, like crew members. She's going to just pack as many fields as possible there. She's going to try doing another request, maybe fetch all the officers and all their assignments, and then try to pass as many fields as possible. And so she can just get as much data as possible being returned back, being processed on the server, creating, taking up CPU cycles, bypassing the rate limits, again, keeping our database busy, hogging up memory, and then with the hopes of just crashing the servers, causing a DOS attack. So how do we solve this? Oh, well, actually, one more thing is, so if this one seemed like kind of like, whatever. Well, think about this request here. What does this request do? Well, it's just gonna, depending on your server backend, yes, it's just only gonna return back one field, but the thing is depending on your backend implementation, your server is still gonna parse this, it's still gonna process this, it's still gonna resolve every single field that exists on that request, locking things up. So if you weren't convinced about this, think about this one instead. This one's a little bit more clever, and it's like, that's not how you're supposed to use it, but GraphQL lets you. So how do you solve this problem? Well, you add a cost to everything. So if we can add a cost to everything, we can limit the amount of stuff that O can get back. So in this case, I've added a little tiny little tag on there. So the name field, it's like a standard string. Maybe add a cost of 1. But the current location's a little bit more expensive. The current location's actually getting live data coming in. So we should add a cost that's much higher, let's say 100. And then what we do is then for every request that happens, we add a cost limit. So let's say we could say like the requests that are being resolved can only have a max amount of 500. So then when it's going through the parser on the GraphQL side, it will look at all the fields before it even tries to resolve them, tally up the cost of that, and then block it. The other thing to think about too is that with lists, so with the previous request over here with crew members and officers, those could be simple lists to begin with small crew, like a shuttle pod or whatever. But when you're thinking about star bases and starships, you're getting 500, 1,000, 10,000 people potentially. And if those lists are unbounded, then you can just overflow everything. So what you want to do is you want to try to move anything that's returning back to list, ideally to use a connection. So we can limit and we can page information instead of letting them pull 500, 1,000, 10,000 records coming from the database. And then once you implement all those different things and the parser has the costs and the cost limit, then we'll get a nice little error saying cost limit exceeded, and we've helped block O from doing anything more nefarious and trying to overload our server with fetching too much information. All right, so aliases. So aliases are great. If there's 2 different fields of the same name, we're able to alias them and grab them too. So if we want to get James T. Kirk and Spock, we can easily do that, and we get them both coming back. But aliases are kind of unique too, because not only can we just do multiple aliases, but we can potentially use aliases for something nefarious, and L loves it. You can also use aliases on mutations. So if you use an alias on a mutation, you can do a brute force attack on it. So in this case, O figured out, hey, why can't I just use aliases to try to do security overrides? So she's just going to go through and just keep on trying, just brute forcing it. And the beautiful thing is, just like with any brute force attack, if you try enough, you'll get the access granted. And why is this bad? So yes, it's a brute force attack. It's clever because it gets past all our depth limits. It's clever because it gets past the cost limits. It gets past the rate limits that we have on the API, because we're not doing multiple requests. We're doing all the requests. We're doing all the resolutions for our mutations in one single request. And then also, aliases have an additional bonus that actually, depending on your backend implementation, it could also overload your servers, because an alias has to be tracked on the server, it has to be kept in memory, because after each mutation or each alias is resolved, it has to be reassigned back to that tag that they assigned it. So if there's an unbounded amount of aliases, then you have the possibility to be hogging up resources on the server, and if you're just And if she's just doing a coordinated attack with a bunch of different requests coming in, then then you could run out of memory and you crash the server. So like with all the other ones, one of the strategies is either you can disable the aliases altogether, but if you need aliases, if you want them, then you need to limit the number of aliases. And sometimes with some of the servers implementations, this can come on by default. Again, there's other implementations that it doesn't, so you'll have to do another third-party library or whatnot, or do a custom implementation. And then after we do that, we get a exceeded warning on there, so we just limit that, or in case if you just disable aliases altogether, then it just won't work, period. All right, let's talk about directives. Directives are awesome. We have the standard directive, the if directive for the client side, so we can just conditionally apply if we want to show off pull the engine data if we need the warp core engine information. But also they're awesome because we can create custom directives. And given that Starfleet is a multi-species organization, we need to internationalize all our stuff. So we created a directive to help translate stuff. In this case, we can easily translate something to Klingon for if one of our crew members needs things to be in their native language. Really awesome. O likes that also. So you can also abuse directives. So in this case, the custom directive. So O identified that our custom directive takes up a little bit of time to process. So when she added it in, she noticed that it took a couple of milliseconds longer for requests to come through. So she's like, okay, well, what happens if I just repeatedly use this directive over and over again? And the cost to that is, we can keep. She doesn't know exactly what's going on, but it has the chance. Depending on the implementation of the directive, they can be keeping the database busy. They can hogging up CPU, hogging up memory, and eventually hogging up the server with abuse of all those directives. And eventually, we just get information overload, and everything crashes. So with directives, the best approach for directives is to either disable them, if possible, on the client side, limit their directive usage. So just like with alias limits, we want to do directive limits. And then the other thing to do is either avoid or monitor any custom directives that are being implemented. So you want to make sure that they either optimize pulling from a cache, that they're not doing it or timing them out. You want to make sure that any custom directive is limited so that it's not just hogging up any CPU, any memory, any database time. All that type of standard stuff. So, with that being said, let's recap kind of the stuff that we covered thus far. So we talked about disabling introspection, not just graphical, but actually disabling the introspection query. That was also covered in the last security talk. Can't underscore that enough. Disabled field suggestions. Another basic one that you have to make sure to do. It's actually surprising how many GraphQL servers don't disable this in production by default if you're using different, especially from different languages. So make sure that those are disabled by default. The query depth limit, implement that too. Cost limit, same thing. Add some cost, and also sometimes with the different implementations there's like a default cost limit that is applied to all the different field types and stuff. So if you identify certain fields that are taking longer, make sure to customize the cost of those fields so that you hit the limit sooner, especially for those ones that are costing more. And usually you can use analytics, APM, Datadog, and stuff like that to do those analysis of those queries that are taking much longer, so you can increase those costs, especially if you can't speed them up through caching. And then disabling or limiting aliases. So you want to make sure to limit those aliases, maybe even just like all together, like in the mutation example, just limit aliases on mutations if it's not enabled by default, because another tactic for another brute force attack. And then for directives, you want to disable, limit, or just monitor directive usage. So to make sure that they're performing correctly. So just like with the cost limit, kind of monitoring the fields themselves. You want to just, if you're using custom directives and you're not exactly sure how they're being used or how they're going to perform, check some monitoring, add some logging around those things to make sure that they're not being abused or exceeding exceeding certain request timing. And then I just want to underscore again that each GraphQL server customization will be different. So I've experience with doing with Apollo server, but also with Ruby and with Elixir. And each one, your mileage can vary in terms of its customization. But with that, is it time to celebrate? Like, did we cover all the basic things? And is our GraphQL secure? Is our GraphQL graph secure? Not necessarily. Just like with the past talk, just like with the previous talk, there's loads of stuff that can happen. There's still loads of customization. There's loads of strategies. So I just wanted to show like some screenshots. So I pulled one like for the Ruby GraphQL. They already have limits set for depth and complexity that you can automatically enable and set. These aren't actually enabled by default, so you have to like go in and just set those variables in here. If you're not sure, or if you're running like a GraphQL server that doesn't have these set, that is node-based, GraphQL Armor is a very lovely library to integrate by the guild that you can integrate into your server, and it automatically enables these by default with already set limits. Great documentation on everything. And then also, if you just want to learn more about GraphQL security and actually learn how to attack your own API and all the tools. So the DynaSec people were in the last talk were kind of mentioning a couple tooling. Well, this book will tell you all the tools you can use, help you set up a Kali Linux instance, and have you actually attack a sample GraphQL API to learn for how these things happen and how you can fix them. For all those things I just mentioned, for everyone that's taking photos with their phone, I did create a little blog post with listing those different things. So you can scan this QR code up here to get all that information. That might save you a lot of time and wondering what the hell did I take a photo of. I'll just make sure that everyone catches that real quick. Cool. The obligatory feedback slide for everyone. But I'll bring this back so you don't have to worry about it. I'll just talk about this. But I just wanted to say that thanks everyone for watching the talk. I know it technically overlaps with puppy playtime, so I really appreciate everyone being here instead of playing with the puppies. Although now that you know about it, I'm pretty sure you're going to run off now. But yeah, so talk to me Guzman on most of all the socials. My website is Talk to Me Guzman Codes, where you can find all my socials also. And I will be at the desks today out there right next to the main hall if you want to talk about GraphQL security, or if you want to talk about Star Trek and why Picard Season 3 is the best season of all the Picard seasons. And thank you again. And if you have any feedback or anything, I would love to receive that. And so please do. And thank you for your time.